Have you ever found yourself diligently training a machine learning model, watching its performance metrics change with each passing epoch, and wondering how to tell if it is truly learning or just memorizing? It is a common challenge for anyone building intelligent systems. Well, learning curves provide a remarkably clear visual signal that your model is overfitting. They plot your model's performance, typically loss or accuracy, over time as it learns. When the validation performance stops improving or begins to degrade, while the training performance continues to get better, that is your strong indicator of overfitting. The core mechanism behind this lies in understanding what overfitting actually means. A model that overfits has essentially memorized the training data, including its noise and idiosyncrasies, rather than learning the underlying patterns. Learning curves make this visible by showing two distinct lines, one for training performance and one for validation performance. Initially, both curves should decrease for loss or increase for accuracy, showing that the model is learning useful patterns. However, if the training curve continues its positive trend, while the validation curve plateaus or moves in the opposite direction, it reveals that the model is no longer generalizing well to new, unseen data, even as it becomes perfect on the data it has already seen. To use learning curves effectively, you should plot both the training and validation loss or accuracy against the number of training epochs. Pay close attention to the point where the validation curve diverges from the training curve. This inflection point is crucial, as it suggests the optimal number of epochs to train your model before it starts to overfit. You might then consider stopping training at that point, or using techniques like early stopping to prevent further memorization. One insider detail is that the gap between the training and validation curves, often referred to as the generalization gap, is itself an important metric. A large and widening generalization gap explicitly quantifies the extent of overfitting. Furthermore, a consistently high validation loss from the beginning, even if it does not diverge much, could indicate underfitting, which is a different problem altogether, highlighting the versatility of these curves for diagnosing various training issues. By systematically observing the trends and divergence in your learning curves, you gain immediate, actionable insights into your model's training process. This visual diagnostic tool empowers you to fine-tune your training strategy, prevent overfitting, and ultimately build more robust and effective machine learning models that generalize well to real-world data.